All right, welcome everybody to another episode of the Puget Systems podcast. This month, yeah, because we're not doing weekly anymore. Still trying to get into the flow of all this. This month, we're going over the NVIDIA GeForce RTX 40 Super Series content creation review, the kind of the conglomeration of all of the benchmark performance results that we've collected for the new RTX 40 Super Series. Yeah, and as always, I like to introduce everybody. We'll go around clockwise, I think. Well, at least from my perspective. Kelly?
That's me. Okay. I'm Kelly. I'm the 3D virtual production game dev. I think we recently changed my title, but I don't remember what we decided on. Up here in labs, and I just do anything in 3D is my realm.
Right on. And Matt?
So I'm in charge of the whole labs department now, but my focus right now is still in the media and entertainment world. So video editing, photography, although really in the context of like GPUs, we don't really look at anything photography based very much. Like Photoshop, it's not really a big deal. Lightroom has some stuff, but stuff we can't really test easily. So it's mostly like Premiere, Resolve, that kind of stuff.
And Evan?
Yeah, I handle most of the hardware side of stuff. So a lot of that is hardware swaps, making sure we're actually running benchmarks, but then also focusing a little bit more on some of the specifics of the hardware that we're actually using to just make sure that as a labs team we're fairly up with what are the differences between some of these on a hardware level and not just the performance level.
Nice.
Yeah, and some of that was really interesting this time around. I wasn't aware of. I mean, I'm sure we'll get into it, but some of them, you look at the base level specs and you're like, it's not that much different. And then I know you were talking about but the memory bus width is different. It's like, oh, well, that's why you're seeing different performance.
Yeah, that'll be interesting to get into. And I suppose let's just dive right into it. I will share the article and. Oh, it might need a little zooming from your end there, Matt.
Let's see, because I zoomed in to the point where charts would fit, but yeah, it looks like we can go one or two more steps. Sure. So yeah, I mean, we have this whole article. Sometimes we break apart articles to really deep dive into a specific application. Didn't do it on these super cards. I mean, this is kind of it's an update to an existing product line, really. It's nothing super new. So we just have a single article in here. But lots of information in here. In fact, probably the place to start is just specs, right?
Sure.
Evan, I think you're the most familiar out of all this. You mind kind of giving a brief rundown?
Yeah, so like most kind of intergeneration refreshes, this is a lot of what we already had, but a little bit better. So for both we have three new cards, right? We have the 4080 Super, the 4070 Ti Super, and the 4070 Super.
Mm-hmm.
It took a lot of work to not make lots of super jokes in the text. And two of those are kind of just slightly better variants from what we had before. So those are the 4080 Super and the 4070 Super. In both cases, it's the one we had, but with a little bit more CUDA cores, maybe a little bit higher clock speed. The idea basically being that, over time their process gets better, and so they can start giving slightly more performant chips into the GPUs. The 4070 Ti Super is a little bit different. Historically, the 4070 Ti used the 8104 chip. For the 4070 Ti Super, they actually moved up to the 8103, which is the same chip that we use on the 4080. And so the 4070 Ti is more like a 4080 Lite than a 4070 Super.
Huh.
If you'll pardon the pun. So broad stripes then is that everyone saw a 5 to 10% increase in CUDA cores. A small clock speed bump, not a huge one. Power limits are basically all the same except for 4070 Super. And in terms of price, they're priced fairly similarly to what they were already, except for the 4080 Super, which got a nice $200 price cut.
Yeah,
which
that's
is
nice.
Really, I think bringing the GPU where it should be priced, but it's definitely nice to get more performance for less money. We're fans of that here.
Oh yeah.
Once again, the 4070 Ti is the interesting one because it got an additional 4 gigs of VRAM. So if you need that 16 gigs of VRAM, you have it now. Again, that's because it's on the 8103 chip now. And so it has, just like the way the memory architecture is set up, it can support 16 gigs of VRAM. It has a larger memory bus width that's relevant for some workflows. And so it really kind of pushes it up a little bit more for some workloads anyway than you might otherwise expect, just looking at like the CUDA count.
Yeah, the things with these cards that I noticed as I was reviewing for this, because we put this article up about a month ago, because now that we're doing these streams monthly, things get spaced out a little bit. The couple of things I noticed was, one, the pricing is really consistent this time. It's a $200 to go from the 4070 Super to the 4070 Ti Super, and then $200 to go from that one up to the 4080 Super, which for us, like in our product line, makes it kind of tough, because that's pretty tight like pricing variations, because we try to simplify our product line as much as we can, which I believe this time around we decided not even to carry the 4070 Ti Super. We're just going straight from the 4070 Super to the 4080 Super, which is kind of interesting because in our article, if you actually read it, the 4070 Ti Super is probably the most interesting one for all the things that Evan was saying. Like the bump from 12 gigs of VRAM to 16, maybe for a lot of these like workflows, it's not a huge deal, like especially for like, you know, video and all that. But just from my own experience of playing around with like all the new AI stuff, like Stable Diffusion and LLM stuff, that extra VRAM would be really nice in my system. I think I only have 8 gigs right now, and like, man, 16 would be awesome. And for the same price that you were getting 12 gigs before.
Yeah, that's so cool. I've heard from there's a lot more of the enthusiast side of things, but I feel like the 4070 Ti Super is really the one that is kind of the breakout, like stellar.
Yeah, I still think for like most people, like if you're building your own system or like, hey, you don't really need a huge GPU, like the 4070 Super is still terrific. I mean, for $600 getting 12 gigs of VRAM these days, and the performance is pretty good. That's a great value. But man, $200 to go from 12 gigs to 16 gigs and get a good performance bump that we'll be talking about in a bit, like more than it would look like from the CUDA cores of only going from 7,000 to 8,500. Like it's a lot more of a performance bump than that. Yeah, it's just that 4070 Ti Super is probably, if I was going to be buying a GPU, that's probably what I'd be looking at. But
yeah, I think it's also a little bit interesting just in terms of looking at the last generation, because one thing we ended up seeing from 30 series to 40 series was all of that memory bandwidth got cut down. So like currently the 4070 Ti Super, the 4080, they're all 256-bit. That was what 60 class cards were for the 3000 series. So in some ways we're kind of seeing like not quite what 40 series should have been. Like obviously there's a lot that goes into designing a GPU, but in some ways like what we were expecting 40 series to be, with that little bit more memory capacity and bandwidth. Since like quite frankly, for a lot of things, 12 gigs is a little bit on the low side, but 16 gigs, you're starting to get into more of a territory of like, oh, this is like going to be good for a while for a variety of use cases.
Nice.
I'm hoping for the 5000 series that 16 will be the base, and then it goes up from there. I doubt NVIDIA will do that, but I feel like we're getting to the point where 16 is going to be like the entry level stuff.
no
I mean, that makes
more than
sense.
16 gigs, right?
Right. Yeah. Sure. 64 kilobits of memory is all you ever need. Right. All right. So I guess let's jump into the results here. If we just go down the list, it looks like video editing for Resolve is the first one, Matt.
Yeah, sure. Yeah, I'll just keep scrolling down here. I think I got to zoom out a little bit to fit everything in. Yeah, so DaVinci Resolve is one that's kind of a staple for testing GPUs for like media and entertainment. Resolve is really good at using GPUs. It's actually really good at using multiple GPUs if you have the paid studio version rather than just free. And so like this is probably the, you know, with the exception of now some of the newer AI workflows that use the GPU even better, Resolve is really like the poster child for GPU performance in media and entertainment. And you can see it it's kind of interesting. So the 4080 Super and 4080, that's these two right here. Almost the same. It's basically margin of error. So like those extra little bit of CUDA cores and stuff, not really doing anything here. So it's really just like, hey, you get $200 cheaper, same performance, great. If you already have a 4080, yeah, there's zero reason to upgrade. But if you're on an older system and you're looking for a new system, it's basically free performance for $200 MSRP less, which usually I believe it'll be even a little bit bigger of a price difference than once you get it into like a system like from us or something like that, just because of markups and stuff. So it'll be a little bit more even. So that's right there. The other thing that's kind of nice is that price drop actually puts it the exact same price as the 7900 XTX from AMD. So it's no longer, hey, you're paying a NVIDIA tax kind of a thing.
Nice.
To get the same performance in Resolve. It's the same price, same performance, and then it just comes down to like, well, AMD is a little bit better in Resolve for processing like H264 and HEVC. NVIDIA is better for GPU effects and or not GPU effects, raw processing and things like that. Moving down to the 4070 Ti, we were talking about, that one's the most interesting, and you can kind of see here why. I believe that's a 11. It's in the text down here. Oh, 19% performance uplift, which is, terrific.
Wow.
That's a great, same price, same wattage. You just get more RAM and a nice performance uplift. So, cool. I'm all about that.
Yeah.
For a lot of my stuff, the 4070 Super... I know it's different, Kelly, for some of your workloads, but for mine, it was not really all that interesting. So the 4070 Super is the only one that had a price increase, which is only $50. It's not a big deal, but that's still almost 10% at that price level. It's also a little bit hotter. I believe it's 220 watts versus 200 watts, so a bit higher thermal output, a little bit higher noise, and all that jazz. And it was a little bit faster, but kind of it's the same amount faster as the price increase. So it's kind of one of those it's just a little bit tough there. It's not bad, but it's no 4070 Ti Super or anything like that, or same thing with the 4080 Super where it's a price drop. So yeah, it's kind of these are good upgrades, especially as you go up. I would say it just kind of depends on what you're prioritizing. I will point out that this is the GPU effects portion of our benchmark, which is the maximum. We do have other scores for overall, across everything. There you see smaller because there's still a lot of stuff in Resolve that uses the CPU only. So when you combine all that stuff, or raw is another one where it's not as big of an increase. You get kind of diminishing returns. So yeah, overall, I like the 4070 Ti the most as far as an upgrade versus the previous generation. 4080 Super is probably going to be our go-to on a lot of systems still. And then the 4070 Super is still a great value. It really is a great value for people who aren't doing this kind of stuff. They're doing, more, they're looking for a general GPU. It's still terrific. So yeah, that's great.
Yeah, it's nice to see AMD kind of higher up the list than usual. On this. That's really nice.
AMD and Resolve does pretty well. It can't keep up with the 4090, but in certain things, what's some of the examples? H264 and HEVC. Oh no, that's right. In Resolve, it's bad. In Premiere, it's good. So it's which application?
That's weird.
Using?
Huh.
Yeah, and it's actually kind of the exact same thing with raw media in Resolve. AMD does well, in Premiere AMD does poor. Different applications, even if they're doing the same thing. Different software developers, they do things differently. Their pipelines are different, and it just results in different stuff. It's one of the reasons you can't just look at one workload that's similar to what you're doing. You really got to look at the actual application.
Yeah.
So with that said, jumping down to Premiere, kind of same stuff here. 4080 Super, basically the same thing. Small, but it's margin of error. 4070 Ti Super, nice little performance bump. 4070 Super, a little bit more of a performance bump here, so it's a little bit better value as far as like, hey, you're paying 50 extra bucks, you get a little bit more. But just because we were talking about those other ones, I guess here, so like this is long GOP, so H264 and HEVC. Notice, yeah, now AMD is at the very top. All of NVIDIA is basically margin of error. The fact that all the supers are at the bottom and the non-supers are at the top is just chance. And in fact, actually, one of these, it looks like we've got an oops. One of these is probably a 4070, and it just happened to have the same score, which kind of screws up our charts sometimes. So yeah, all basically the same thing. And then raw, yeah, you'll see AMD's way at the bottom now. So yeah, just really shows how you have to look at actual like applications you're using. You can't just like, yeah, that's close.
Yeah, no, that's crazy how different that is.
Yeah. When it's supposed to like, because when you're working with like raw footage, like Adobe's not making their own raw decoders and debayers for Red or Blackmagic Raw or anything. They're using what comes from the cameras. So like there's an SDK, a software development kit. So it's just how well it integrates into their existing like GPU pipeline, which is way beyond me as far as like programming goes. But interesting still. But yeah, that's really the only things we tested as far as like media and entertainment goes. I mean, Kelly, a lot of your stuff really overlaps now. But yeah, we didn't look at Photoshop. Really, GPU makes no difference there. As long as you have something, it's great. Lightroom, same kind of thing. So yeah, that's everything from me. And then yeah, I think we can skip down to Unreal.
And often enough, often enough, I see questions about how does any of the local hardware have any effect on any of like the new sort of like AI generative AI stuff built into like Premiere and Photoshop and things like that?
Depends on what it is.
Okay.
So things like Photoshop, they have their new generative fill. That is completely cloud-based. Local hardware has no real impact on it. Like, I'm sure if you have a terrible CPU, like, yeah, just like packaging that up and sending it off to the cloud and downloading stuff will affect it. But like GPU makes no real difference. They do have other things like a select subject that's AI-based, a few other of their upscaling things. Some of those are GPU, but they still use the CPU heavily to the point where like, cool, you've improved, like, this is the entire thing that like Photoshop is doing. This portion is GPU, so if you make it this portion, this much shorter, it doesn't really change the overall all that much. Okay. And then like Premiere, there's actually quite a few stuff in there that's not even using the GPU, even though it's AI. It's like so fast that like they're like, well, we'll keep this is my theory, is that they'll keep the like much easier to have cross compatibility via CPU than trying to deal with OpenCL versus Metal versus CUDA. So if it's fast enough already, they just keep it on CPU. I think some of the like auto transcribing stuff is still CPU based. Some of the other things do use GPU, and in fact, for like DaVinci Resolve, that one's heavy GPU. And the benchmark update we're working on for our Resolve benchmark will have a bunch of the AI features in it, and that should show a lot of GPU performance. Some of those things I'm still not convinced people are really going to use, but some of it I'm sure will. Sometimes it feels like they're just playing shotgun and just throwing stuff at the wall to see what sticks.
Sure. All right, Kelly, how's the Unreal looking?
All right, so Unreal, obviously a 3D application, so therefore it's going to use video cards pretty heavily. And it's a little bit of a different story than we saw in the previous stuff, because again, 4080 Super is exactly the same as the 4080 non-Super. You're just saving $200. But the 4070 Ti only sees a 5% increase here, whereas the 4070 Super has a 16%. So like it's kind of flop from all of Matt's stuff, where the lower end things actually did much better than the 4070 Ti Super, which is strange, I guess. I don't know.
Yeah.
But at least you're getting a lot more performance for that extra $50 you're paying. This does not take into account VRAM necessarily, this benchmark, because it has to be kind of designed to work with all sorts of VRAM. So it doesn't really like stress that enough. And there could be a difference there where if somehow your scene is taking 14 gigs and so therefore it'd go over the frame buffer on the 4070 Ti, 4070 Ti Super would have a bigger performance increase. It just gets difficult to benchmark because we'd need something that like sits in between each VRAM level for all the GPUs to be able to actually test that, and that just get complicated. But yeah, the 4070 Super actually did really well here. Anything else to mention with that? Not really. Oh, we did include charts for average FPS, ray trace, and rasterized performance. That doesn't really affect NVIDIA GPUs much at all. The only difference you see is in rasterized, the Radeon jumps from at the bottom of the charts to the top of the charts. That's just because NVIDIA is just way ahead in ray tracing technology. So, but if you're not using that, if you're doing game dev for a game that's not using ray tracing or hardware accelerated ray tracing, the Radeon does really well.
Nice.
But it doesn't really affect the supers much at all.
Yeah.
How many people are actually not using all the ray trace stuff in Unreal though these days? Like, is that still common?
Yeah.
Still?
A lot of games just don't use it. They're trying to target lower end hardware, mobile stuff. Even things like the Nintendo Switch does not support hardware ray tracing. So a lot of game devs just don't use it because it's not necessary. Or if your game just has an aesthetic that doesn't really lend itself to realism, like why do the hardware performance hit? Especially since like Unreal 5's Lumen lighting system, the target is 60 FPS on a modern console. Like that's the highest you can go, and this is a pretty decent hardware too. So if you're targeting lower end hardware or just want higher FPS, you turn off hardware ray tracing and you get much better performance. But usually it's an either or. So like you can do both. You just get better performance with it turned off, but better visuals with it turned on. So
is that why like game devs, like sure, AMD's great here, 4080 Super is basically the same price, but then it's way better if you have ray tracing on. So that's why you would end up going with NVIDIA. You know, it's just because of like, if you decided you wanted to be testing it, man, it gets a big boost, and at worst, it's about the same.
Yeah,
gotcha.
Exactly. And then going on to GPU rendering. This is not the class of cards that would really be used for GPU rendering necessarily. Like you can, there's no reason you can't, but you want the fastest card you can get. And so this is kind of on the middle to low end for GPU rendering. Here we actually do in Cinebench anyways. We see the 4080 actually has a decent, it's like I think the only test we have where the 4080 actually has a performance increase, the super over the 4080 non-super. Not sure why. Here again, the 4070 Ti super has a huge performance increase, and the 4070 super is less of an increase. So that's more in line with what we saw in Photoshop, not Photoshop, but DaVinci and stuff like that.
It is interesting though. Yeah. Sorry, just before we move on, it is interesting how the 4070 Super is the same as the old 4070 Ti almost exactly. And the 4070 Ti Super is almost exactly the same as the old 4080.
Yeah.
Even though was it $400 cheaper than the old 4080 non-super. It's like that's pretty good. Like same performance, $400 less.
Nice. Yeah, that's awesome.
Okay, you can move on to Octane now. I just wanted to, I thought that was interesting.
Octane is more of what we saw before, where the 4080 Super is neck and neck with the 4080. There's no real difference. It's within margin of error. The 4070 Ti Super is a big improvement. 4070 Super is slightly less of an improvement. This one does not support AMD, so that's just blank.
Weird.
They keep talking about adding OpenCL, right?
Yeah.
Maybe. If Intel throws enough money at them, maybe.
You mean AMD?
Well, I think they're
OpenCL,
kind of both, right?
Yeah.
Yeah.
Well, AMD is using Rock M now, and yeah.
Oh.
So V-Ray, I feel like a broken record. Actually, this one has again, the 4070 Super actually beat the 4070 Ti non-Super. So you get a nice boost there. But everything else, 4080 Super, same as the 4080. 4070 Ti had a really nice boost. It's not quite catching up to the 4080 like we saw in Cinebench, but still really good. And then might as well just jump to Blender. And again, exact same thing. Yeah, rinse and repeat. 4080 really has no difference. 4070 Ti is slightly better. 4070 is a little bit better.
Which is
then,
why we threw all of the GPU rendering charts into one gallery.
Yeah.
And then AMD is down at the bottom. It's one of the few that supports AMD hardware.
I think that's everything we tested, right? Yeah, that's
Yeah,
pretty much it.
yeah.
I do know we want to add more stuff in the future. I know we want to do more AI stuff. Like we want to get Stable Diffusion in here, maybe even some LLM stuff, because it sounds like people are interested in running LLMs locally. I'm not quite sure why, but cool.
Because they don't trust the hallucination cloud services.
Oh, maybe. And then I still want to get in, like I want to bring back, we did Topaz, like AI for video and photo stuff for a while. I want to bring that back. It was tough back when we were using it before because they would put out an update like every 2 weeks that would break all of our automation. But hopefully it's been out long enough now that it doesn't break things.
I want to grab this question from YouTube. LF2021 asks, what brand cards do we use since EVGA is gone?
So most of the time we try to do the founders cards quite a bit. So that's kind of our bread and butter. That doesn't always work because like the 4070 Ti, I think, doesn't have a founders version. Or it's one of those that doesn't. It's weird.
The TIs don't have founders, yeah.
Yeah, okay. Which actually we're not using in our workstations anyway, so I guess it's not a factor this time around. But that has come up before. Beyond those, I know we do a lot of Asus and Gigabyte. We have a whole like tier list though internally, and I'm not familiar with what their tiers are. I know it changes based on like what our contacts are at those companies, you know, as people move or change departments or whatever, as well as our qualification and like failure rate analysis and everything like that for specific models. So it changes sometimes, but I know they have a tier list of like, FE cards straight from NVIDIA, and then maybe a Zeus and a Gigabyte, or sometimes it might be switched. Maybe Gigabyte will be first and then a Zeus, but
kind of like our motherboard choices. Just kind of depends on who's doing the best at the moment.
Yeah, and it's best for us too, which is very different than end users. Because again, best for us might be who gives us the best like BIOS support, where like if we find a problem, hey, they can fix it, versus another company might be better 90% of the time for end users because they have less problems from the get-go. But if we do find a problem, we can't get it fixed. So like it's very different for us than end users, I would say.
Well, and this time around with the 40 series, because the cards are getting so massive, some of these third-party cards, like their coolers were even bigger than NVIDIA's, and so now we're having troubles like bracing it, compatibility with getting other add-in cards into the system with these huge things. So it's like, if you can deliver us something that's within 3 slots, maybe we can use that one. But if it's 4.5 slots, we're probably not going to use it.
Yeah, we have in the labs testing room, we have the Asus ROG Strix, like 4070 Ti and Ti Super. And those are, I think, almost 4 slots. They're bigger than the 4090s. They're massive. So
that's intense.
Yeah.
Wow. There's a question sort of spread across a few messages here, but Tech Notice on YouTube asked, was that Blender 4.0? I clarified that it was 3.6, but they were curious as to why 3.6 and not 4.
It is actually 4.0.
Was it 4.0 for that one?
Oh, the chart says 3.6.
I apologize. That's a typo on the chart. I just re-uploaded all those charts because Matt noticed a different issue. and I must have forgotten to get that fixed. So it is Blender 4.0.
Okay.
You were going to say
Is
something
there a
about it, though, Kelly, right?
Kelly? Yeah. What were you going to say there?
Well, I couldn't remember if it was this one or what, but there's one of the testings we did where like we literally finished testing, hadn't published yet, and then they released Blender 4.0, and I was like, was this that article or not?
I think that was the Threadripper Pros.
Okay.
Yeah.
And then as far as 4.0 being slower, I haven't noticed that. Maybe if you're using some of the newer features, but the Blender benchmark doesn't reflect any, I don't see any difference in that. Everything else we're testing is on 4.0.
Cool. Right on. Okay. And let me see here. And I guess, are we carrying the entire Super series or?
No, in our product line, it's just going to be 4070 Super, which I believe we've already moved over to. And we are about to move over to the 4080 Super. I think we just had a little bit of stock we had to get through, and I think we're down to like a handful of cards. So once we do that, that will be a little bit annoying because like it's a price difference. But that's the problem for the consultants.
Yes.
And then the 4070 Ti Super. We were talking about this at the very beginning, but I'm sure there's more people in now in the stream. That's probably the most interesting card in like all of our testing. But because the pricing is so close between all of these cards, like going from the 4070 Super to the 4070 Ti Super is $200, and then go from that to the 4080 Super is only $200. That's really tight for us because we try to keep our product line as slim as we can. Like the slimmer our product line is, just the better for everyone. So usually about a $400 difference is about where we're targeting for between like different levels that we offer our customers usually. And so even though the 4070 Ti Super is, I think, my favorite of like these new GPUs, it's the one that we're skipping over in our product line just because otherwise it just gets too many things. Because every product we carry is actually more like 3 or 4 products because we have alternates and brands and different things for when supply gets wonky. And so like it's a lot of work for every single product we carry. So I believe we're skipping that one.
And for a lot of things, like the extra $200 for an entire system cost to jump from the 4070 Ti Super to the 4080 is actually well worth it. So you might as well just get that one. Or if you don't need that performance, drop down to the 4070 and have that. Like, kind of just, they're so close together, it does make it difficult.
Yeah, you're right. All right, $200 seems like a lot when you're talking about $400 to $600 because that's like a 50% increase or whatever. But when you're talking about is going into a $4,000 workstation, $200 is like, yeah, I'll do that. Like, it seems worth the investment.
Yeah, definitely for like DIY side. That's what I like to do. The 4070 Ti Super seems super fantastic though. Compare that like 5800 X3D seems like, or 7800 X3D nowadays, I guess. Seems like you have a pretty solid, just kind of like enthusiast build going on.
Yeah.
Even some of the not to derail the conversation away from GPUs, but some of the Intel like 14600 and 14700, like they had incredible performance for their price. Like, you can make a nice entry level build with some of that stuff.
And I want to grab this one as well from YouTube. JM Ricks asks, might not be the right place, but if we have a Puget system that's a couple years old, like with the 3080, is it possible to just buy a card and upgrade on our own?
I'll take that again here. Yes, absolutely. We don't sell parts to non-customers. We used to do that, and it was just a pain and awful. But if you have a system that you're upgrading from us, absolutely. There's a couple of different routes we take. Always like the preferred method is send your system and we'll do the upgrade. We just charge you the cost for the part because every system we sell has lifetime labor warranty. So like you don't have to pay labor for us to swap it in, update drivers, make sure it's not gonna break, that kind of stuff. So yeah, if you have a system, that's our preferred method. But I know they do also like, hey, yeah, you want a GPU, cool. Put together an adjustment order and then we can ship it out. And I'm sure they have a whole process, the support team of like video walkthroughs or like get on your phone on a live chat, and that way like if you have questions you can even look at it. Because doing some of these upgrades can be a bit tough because GPUs have just become higher and higher power draw. And like these new 40 series have a 12 pin connector. It's a different connector. And so you have to use an adapter from that to, I mean, it depends on which GPU you have, but either a single 8-pin, dual, or I think the 4090 even needs 3 8-pin plugs. So they'll also want to double check, like, hey, is your power supply big enough? Do you have enough power connectors easily available? Because if you have to add like another power connector, that's a lot bigger of a thing than just taking an old GPU out, putting a new GPU in. Plus, the other reason we like to get systems in is then we can update the bracing. Because like even if you're not talking about shipping your system, you know, because if you swap the GPU yourself, you're not shipping it anywhere. But man, those GPUs are just so big and heavy that even just over time, they will slowly sag down and like they can mess up your PCIe slot over time. So you really do want some sort of like bracing in there to hold it up. I know some people even just use like Legos. Like if they're not moving their system ever, yeah, just grab some Legos from your kid and just like make a little tower and hold it up. Like that works. It's not gonna hold in. You know, FedEx ain't gonna work with that. But
yeah, I actually use. I have the. It's a little robot. It's like a test print from a 3D printer. I think it's from the Ultimaker test print little robot guy. It's just tall enough to keep my GPU end from sagging too far out. It's just perfect. TechNotice had another question, and I think this is actually going to be, this would be a really good topic for kind of a different stream, but they were asking, have we ever considered changing the default Puget Systems PC case to like something like the Fractal North? And I know internally we're all, especially with Fractal stuff, we're always testing those internally. Like, I don't know if it's the North necessarily. I think that's the one with the wood in the front. A lot of us internally were super stoked. That looked super great, and I thought it was going to be a really good product for everybody. But during testing and stuff, I think it was mostly an airflow and cooling issue that we didn't end up picking it up. But I think that's a really good question for, I might get R&D.
Constantly looking at cases in R&D. Like they're just showing up all the time, left and right.
Yeah.
And then the worst part probably for them is then what do you do with it afterwards? Because then you
Give
have
it
all
away.
these giant cases. They're like, yeah, but there's only so many cases even employees need.
Yeah.
I mean, they've never struggled to get rid of them. I don't know how people keep taking them.
Yeah.
I think Houston has taken like 45 of himself.
Only the little ones. I don't do too much with the ATX cases anymore.
Yeah, I do know that we are slowly transitioning to trying to have our own actual chassis. We're doing that with rack mount stuff right now. We have a custom, like if you go to our website, you go to our servers. In fact, you know what? I can even
I was just looking at those earlier.
Can't see it because it's blurred, but I have one of our prototypes back there.
But yeah, like our
secret.
4U and I think 5Us now. They have like a custom front panel. I forget who the base company is. Like, there's actually only so many companies that actually make chassis. Like, it's surprisingly small number. It's just like power supplies. Like, so much stuff is like rebranded.
I think there's primary for like the more just kind of generic like 4 and 5U rack mounts. I think there's 2 different we're using right now. I think we have Silverstone and Sliger, and that kind of depends on the exact needs that chassis has.
Yeah, that's right. Yeah, because we're expanding into like storage stuff too, and that's what I brought up. For some reason, my internet is being super slow right now.
Yeah, same.
Eventually, this will load. maybe it's our server. Maybe we're getting DDoSed or something. Yeah, there we go.
There it is.
And these chassis are actually kind of interesting. I didn't know this until I'm updating some of our systems in our labs department. And the 5Us at least, they actually come with feet, and you can turn them on their side. And then they're like a tower chassis. I don't think they're like, that's not how we're intending on using them. But it is interesting that that's an option. But I know that eventually, John's actually in chat. He says we're being DDoSed by our marketing newsletter. Great.
Hey.
Too many people opening the newsletter.
Leave it to
But I do know eventually we'd like to have like our own custom branded, full on chassis. Like Fractal's been great. Like I love Fractal as a company, but we're starting to get a little large for just using Fractal chassis, I think.
Right on. Well, I mean, I think we've covered it all, and unless we get a few more questions coming in right here at the end, I think that about does it. Again, these sort of in between product launches like this, they tend not to have a lot of panache, I guess. So
next time we have like a when there's not a product launch, because we're trying to do one of these every month, right?
Mhm.
The R&D team would be really cool if you can convince them to come on stream to really talk about like their whole process. Like it's really interesting.
The question from Victor on YouTube is a good one that we will address in the future.
The new mobile workstations.
Oh, maybe off topic. Can you talk to the new mobile? Oh, yes. Funny you mentioned that. That is actually next month's topic. If everything lines up right, there was some question about when the performance testing results and stuff were going to be published. And so big fingers crossed, but I have a high level of confidence that that'll be the topic for next month's stream, actually. So mark your calendars for that. That'll be the first Tuesday of April. I'm not sure exactly. I think it's the 2nd.
Yeah, because we're doing a lot of testing right now for that laptop. We're looking at it compared to like desktops. So just, hey, if you want to go on a mobile workstation platform, what's the performance like versus a desktop of like the similar cost, which is tough because like desktops don't have a screen, keyboard, and battery and stuff. So like a lot of this stuff is like, yeah, you kind of be a little okay with flexibility. But we also want to look at versus the top end MacBook Pro, which has some really interesting performance comparisons actually. So that one's super interesting. And then of course we want to do some like battery life stuff, some thermal things like, which I think a lot of it's going to end up being like, no, you don't want this on your lap, either for battery life or for thermals. But that's true on anything of that this performance level. Like we are not going ultrabook with this laptop. We are targeting. You want to like be taking something around to clients or like to a show. Like we were at the HBA Tech Retreat a couple weeks ago, and like when all these people running like big like LED walls and stuff, like that'd be great if you could just bring a laptop, plop it down, plug it in, and done. You don't have to deal with like shipping a whole system and a monitor, a keyboard, and mouse and all that stuff. If you can just run a giant LED wall off of a laptop, that's awesome. Like so, that kind of stuff.
I guess to maybe spoiler a teeny bit without getting into actual details, the 4090 Mobile is the same GPU as a 4080, just straight up, except it's going to generally have a lower power like overall, but then the exact power settings is going to be set by the manufacturer or the OEM of the reseller potentially of the system. So that does mean you have to be a little bit careful looking at like other laptop reviews, because it might be that one manufacturer has just a larger battery with larger capacity. They can give it more power or whatever. But think 4090 Mobile, 4080 before power limiting. And similarly, the 14900 HX is a 14900K, except more power limited.
And those power limits are interesting. Like this is the first time we're getting back into laptops for a while, so like I'm relearning a lot of stuff, and I didn't really quite realize how much control the manufacturer, the OEM, the white box, whatever you want to call it, has over power limits for the CPU and the GPU, and how much you have to like, because you have a total power limit, and then you have to decide, well, do you want to give a lot of power to the GPU or the CPU, try to balance it? And so it's really interesting. I'm really curious to see like how our laptop performs compared to other mobile like laptops with like the mobile 4090 and stuff. Because I'm just curious, like, did Razer decide to give more power to the GPU and limit the CPU more, which might make it better for like GPU rendering, but make it way worse for something like Photoshop? I don't know. That's a whole world that I'm having to get into, because I'm just used to like, oh yeah, unlimited power in a desktop. You just give it a bigger power supply and you're good. But you can't do that on a laptop.
Yeah, and sometimes those power limits can give you just some like weird, funky results. So it's interesting.
It's fun. A lot of work. And I'm glad we have Evan now.
Sure. Well, all right. I guess we'll just wrap it up here. Thank you, gentlemen, for taking the time out of the day and joining us and sharing the fruits of your labors. And as always, I appreciate the audience for showing up as well. And we're on a new cadence for this. We're going to do this every month. First Tuesday of the month. Next month, laptops. So tune in. Tell your mom. The Bridge Club, whatever. We'll see you then.
Forget.
Bye.